Okay, I'm sorry that I'm a little bit late getting this video out to you all, but I've been on the road this weekend and haven't had much of a chance to get this done. But I want to go through section 3.2 and 3.4, which are measures of center and measures of spread. And I think that some of the stuff, especially with measures of center, you've probably heard before. But I think maybe some of the other stuff you may have heard before, but aren't quite sure exactly what they are. So first of all, here's a distribution of 9 heights of students. These aren't necessarily the same numbers that we worked with in class the other day, but this is just 9 heights. And what I want to do is use this data set to describe things about center and then also things about spread that are in 3.3. So the first thing we talk about when we say where is the center of this distribution, we talked about that in class about looking at the graph of the histogram and just thinking about where this thing might balance. But the way that we're going to measure center is there's really about 3 or 4 different ways we're going to do it. One is we're just going to talk about the mean. Right? And the mean, we're going to use this notation of x with a bar above it. And the mean, your book will use this notation of it's a summation, and then I'll write this as x sub I, and then divided by n. Right? And really all that is n is the number of numbers, which in this case is 9. And then the summation notation just means take the first x, 60, add the next x, 63, add the next x, 65, and just keep adding these up until you get to the end, where we end up with 68 and then a 62, and then divide by the total number of numbers, which in this case is 9. All right, so when you add up all these heights, you're going to end up getting 594, and then we're going to divide that by 9, and when you do that, you're going to get 66. Okay, so 66 is the mean of all these heights. Another measure that we're going to talk about a little bit in this section, but we're not going to use very often, is something called the mid-range. And the mid-range is a very easy way of measuring the center. The problem is that it's not necessarily going to give you a very good measure of the center if your distribution is highly skewed one way or the other. Right? And the mid-range has got a formula, and it's just to take the maximum value and subtract the minimum value, add the minimum value, and then divide by 2. So it's really just take the biggest number and the smallest number and average them. So in this case, the max and the min, the max is 74, the minimum is 60, and then divide that by 2. And when you do that, you're going to get 67. Okay? So these two measures of center are actually, they're fairly close together because this distribution is, it is fairly symmetric and there's not a huge outlier in either direction. All right, but again, the mid-range is something we're not going to use that often. Another measure we're going to be using, or that we're going to talk about in this section, is the mode. And the mode, I don't know exactly that this is a great measure of center because it doesn't necessarily have to be a number that's in the center. The mode is just the number that occurs the most often, and in this case all these numbers were different except there was 2 65s, and so 65 is the number that occurs most often. Right, and in this case it does happen to be fairly close to our other measures of center. Alright, then the last measure that we're going to talk about, and this is one that we are going to use quite often, is the median. Right, and we're going to end up using the mean and the median probably more than anything else. All right, now to find the median, it's really kind of a process. First thing is you're going to put all the numbers in increasing order. All right, so if we put these in increasing order, the smallest is 60, and then the next one is 62, and then a 63, and then there's the 2 65s, and a 66, and 68, and 71, and 74. Right, and then once you get these in order, the median is nothing more than just the middle number. All right, so the middle number in this case is 65. All right, so the median is 65. All right, and again, you can see all these numbers that we end up with for the measures of center are all pretty close to the same thing. Okay, so the mean is something you probably have heard before called the average, and the median is just the middle value when you sort them. All right, now the other problem with the median is that in this case it worked out nice because we had an odd number of numbers, and the median is a number in that list. But if you should happen to have, let's say, an even number of numbers, for example, suppose the 60 isn't there, and we just have these numbers from 62 to 74, then to find the median, we look at where the middle is. The middle would be between the 65 and the 66. And so if that was the case, the median would be 65 and a half. Okay, it's going to be the average of the two middle numbers. All right, so that's kind of one of the glitches to using the median is that sometimes it's going to be a number in the list, and sometimes we have to find the average of two numbers in the list. All right. So measures of center, that is about all there is to it. Now, there is one other thing that we need to be mindful of as well, and it could be that we are given a distribution of heights in a frequency table like the one that we had in class, right? And these are exactly the same numbers that we had in class the other night. And so if we're given, let's say, just this frequency table like this, and we're going to find the mean of these numbers. Right? The problem is that we're not going to be able to find exactly what the mean is because these four people, I don't know how tall they are. Are they 60? Are they 61? Are they 62 inches? Right? And so there's a little bit of a problem with that, and we're just going to be able to approximate what the mean is when we have a frequency table like this. All right, so what we're going to do is we're going to assume that these four people are all the same height. And then we're going to assume that they are the midpoint of this range. All right, so we're going to assume that all four people in that group are going to be 61 inches tall. And then we're going to assume that all 7 of these people are 64 inches tall. And all 8 of these people are 67 inches tall, and so on. And so we're going to end up with 24 numbers added up. We're going to end up with a 61, a 61, a 61, a 61, and then 7 64s, and so on. So we're going to take 61 times 4. We're going to take 60, this should not say 62, this should say 64 times 7. All right, that's going to change this number a little bit too. All right, we'll have to change that in a second. All right, so 64 times 7, and then we're going to take 60, that should not be 65, that should be 67 times 8. This one is right, that's 70 times 3, and then 70 should be 73. I don't know why I got off on these numbers. 73, and this one is 76. Okay, so I've got to recalculate a couple numbers here. All right, so 61 times 4 is 244. 7 times 64, though, that number should be 448. And then 8 times 67, that number is 536. And then that is 210. This should be 73, and that is 76. Okay, so if I take 244 plus 448 plus 536 plus 210 plus 73 plus 76, okay, I get a total height of all 24 people is 1,587, and then I'm going to divide that by 24. All right, so an approximation for the mean height here would be that x bar is about 66.125. Right, and again, that number happens to be, pretty much on target with the other numbers that we had for measures of center. Okay, so that's about all there is in section, what section was that? 3.2. All right, now the other thing we want to talk about is how we measure how much spread there is in a distribution, which is going to be just as important as finding out where the center is. All right, and so in section 3.3, we're going to be working with measures of spread. And there are several of them. One of them is the range. Another one that we're going to be working with is the interquartile range. Another one we're going to talk about is the variance. Another one is the standard deviation. And the last one is called the, I guess I have an interquartile range. We're also going to see this thing called the IQR. You'll see me abbreviate that as IQR a lot. Okay, the range is really an easy way to determine the spread. And the range is nothing more than take the max and subtract the min. Alright, so the biggest number in this distribution is 74, and the smallest number is 60. This distribution has a range of 14. Okay, 14 from the biggest to the smallest. Right. The one thing that I see a lot of people mix up here is that they think a range is an interval, and a range is really a number. It's how far are the max and the min apart, not the actual numbers, the max and the min, but how far they are apart. Okay, now I think that I want to skip over the IQR for right now, and we're going to talk about variance first. And to talk about the variance of this distribution, I think it might be helpful for us to look at a graph of the distribution of heights. All right, so let's graph these. And we've got the smallest number was 60, and then I'm just going to go by twos here. 62, 64, 66, 68, 70, 72, and 74 was the biggest. All right, and I'm just going to do a dot plot. So there was one that was 60, there was a 62, there was a 63, there is two 65s, there was a 66, there is a 71, and a 74. All right, now we're going to be measuring something with the variance. And the variance you'll see is written as just variance. And you'll also see this written as S squared. All right, now the variance is a measure of spread. And it's a measure of spread around the mean. Right, and so what we're going to do is we're going to take every one of these values of x. So x1 is 60, x2 is 62, and so on. And we're going to subtract the mean. All right, now that difference is going to represent how far each number is away from the mean. Okay, we're going to do that for every single number and then add them up. And then we're going to divide that by n minus 1. Right, now, the problem with this is that some of these are going to give me positive values, some of them are going to give me negative values, and so to get rid of all those negative numbers, we're going to square that difference. Okay, so to find the variance for this, okay, we're going to add up a bunch of things in the numerator and then divide by n minus 1. All right, so the first thing that we're going to add is we're going to take 60 and subtract the mean. Now remember, the mean was 66. Okay, from our work before. So we're going to take 60 minus 66, and then we're going to square that. And then we're going to take 62 minus 66 and square that. And then we're going to take 63 minus 66 and square that. And we're going to do that for every one of these until we get to 74 minus 66 and square that. And then we're going to divide that by the number of numbers minus 1, which in this case is 8. Okay, so 60 minus 66 is negative 6, squared is 36. 62 minus 66 is negative 4, squared is 16. The next one is going to give me negative 3 squared is 9. And then when I get to 74 minus 66, that's going to give me 8. And then square that, and I get 64. Right, and then we divide that by 8. All right, now each one of those numbers represents kind of a distance. That 36, the first number here, represents how far it is from 66 out here to 60. Okay, this 16 represents how far it is from 66 to 62. The 9 represents how far it is from 63 to 66 squared. All right, and then the 64 that we get over here is the distance from 66 out here to 74, and then square that. All right, so what we're doing is taking all those distances and squaring them and then adding them up and then dividing by 8. All right, so when we do that, 36 and 16 and 9 and all those numbers added up is going to give me 156, and then we're going to divide that by 8. And when we do that, we get 19.5. All right, now the variance is a number that we're going to end up using quite a bit when we do some calculations. For right now, what you need to know about this number is that when that number is small, that means that there is very little variation between the numbers. Okay, in other words, if we add up all these numbers are going to be small if they are all concentrated around the mean. This number is going to be big if there's a lot of spread in our data. Okay? Now, so the variance is going to be 19.5, and a lot of times what we're going to be using to measure the spread is not the variance. We're going to be using the standard deviation. And the standard deviation is nothing more than, we're going to measure it with S. So if the variance is S squared, then the standard deviation is just going to be the square root of the variance. The variance was 19.5, so this will be square root of 19.5. And the square root of 19.5 is about 4.416. Right? And that's the number that we're going to be using quite a bit to measure or to talk about how much spread there is. Right, now, if you think about what this number might represent, this number can be approximated by looking at these differences up here in the picture. And that 4.46 it's not exactly, but it's pretty close to just being the average distance that these points are away from the mean. Okay, the average distance away from the mean is a nice way to think about the standard deviation. All right, so if I gave you, I wouldn't be surprised to see 4 inches here for a standard deviation. Okay, we'd expect that on average, people are going to be off of the mean by about 4 inches or so. That sounds like a reasonable number. Okay, now the next thing that I want to look at is this idea of the interquartile range. And before we talk about the interquartile range, what I want to do is go back to my sorted list of numbers. My sorted list of numbers were 60, 62, 63, 65 twice, and 66, and 68, and 71, and 74. All right, we said that this number here was the median. Okay, and the median has the property that half the numbers are smaller than it and half the numbers are bigger than it. Okay, the median is also called the 50th percentile. Okay, and it's called the 50th percentile because 50% of the data is to the left of that number. All right, we're going to be talking also about quartiles. Okay, and the two quartiles that we're going to be talking about are the first quartile, Q1, and Q1 is just the 25th percentile. Okay, that point in my list of data at which 25% of the data falls to the left. Right now, if this is where the median is, an easy way to find out where the first quartile is to just look at all the numbers that are less than the median. Okay, those 4. The first quartile is going to be the median of those numbers. All right, so the first quartile is just going to be the number that falls between 62 and 63. So the first quartile is just going to be 62.5. All right, then the other one that we want to be able to look at is Q3, and Q3 is the 75th percentile. It's the place in this list of data where we're going to end up with 75% of the data falling to the left. All right, and an easy way to do that then is to just take the median of the upper half, All right, so Q3 is going to fall right there, and halfway between 68 and 71 is 69.5. Okay, so the quartiles, if you know how to find a median, all we're doing is finding medians of the upper half and the lower half. Okay, and the same rules apply. If there's an even number of numbers, you're going to take the average of the two middle ones. If there's an odd number of numbers, you're going to find the middle value. Okay, now what we're also going to be looking at then is, I talked about the IQR, the interquartile range. The interquartile range is a number, and it's going to describe how far these two numbers are apart. Okay, so the interquartile range is Q3 minus Q1. So 69.5 minus 62.5, that gives me 7. Right, the interquartile range, again, the R stands for a range, but it's not an interval, it's a number. This is 7, and that means that the distance between the first and the third quartile is 7 inches in this case. Right, now the other way we can look at this interquartile range is it's a range of numbers in which the middle 50% lie. Okay, half of the numbers, and not just half of them, but the middle half of the numbers are going to fall between Q1 and Q3. And this number just tells me how wide that interval is. Okay, I think that at this point also it might be helpful for us to talk about another graphical display and talk about how we can describe a distribution of numbers. All right, there is a distribution or a statistic called the 5-number summary. And the 5-number summary is these 5 numbers. It's the minimum, and the first quartile, and the median, and the third quartile, and the max. So for our distribution, that smallest number was 60. The first quartile was 62.5. The median was 65. Third quartile was 69.5, and the max was 74. Okay, so that's a 5-number summary, and a 5-number summary gives me a little bit more information about just where the center is. It also gives me a little bit of an idea about how these numbers are distributed. Okay, the lowest 25% are going to fall between 60 and 62.5. The second 25% are going to lie between 62.5 and 65. The third quarter are going to lie between 65 and 69.5, and then the highest fourth is going to lie between 69.5 and 74. Sometimes I've had teachers in the past that would list a 5-number summary when they talk about how did some test scores come out. All right, and you can really kind of tell then, you know, if you got, let's say, a 70 on this exam, or you were 70 inches tall, I guess, you would know that you're going to be in the top 25% for height if you were 70 inches tall. All right, so on. All right, now the other thing is that this doesn't give me the whole picture. What I want to be able to do is think about, this is 2.5 inches, this is 2.5 inches, this is what, like 4.5 inches, and so on. So I'd like to be able to do is graph this as well. All right, and so if I look at what a graph of this would look like, there's where 60 is, and let's just go by 5s. So 60, 65, 70, and then 75. So if I were to graph this 5-number summary, the smallest number is going to be 60. The first quartile is at 62.5, which would be about there. The median, 65. The third quartile is 69.5, about there. And then the max, 74, would be right about there. All right, and what we're going to do is make a different kind of a graph here. And the graph that we're going to be looking at is called a whisker plot, or a box plot. And what we're going to do is take the first quartile and the third quartile, and we're going to form a rectangle, with the boundaries on that rectangle being the first quartile and the third quartile. Then we're also going to mark where the median is in that box. And then we're going to extend whiskers out to the min and to the max. All right, and so what we can look at here then is we know that 25% of the data is going to be in this whisker, 25% of the data is going to be in here, 25% is going to be in here, and 25% is going to be in here. And so because this part right here is wider than some of these other pieces, we know that from the 50th percentile to the 75th percentile, those heights are spread out more than the shortest people are. Okay, and that's what this is going to tell me. Okay, so that gives me something that we can talk about in terms of a graphical display if we know the median and the quartiles and the max and the min. And it gives me a nice idea about what that distribution looks like. Okay, so we've got that, and we've also got histograms that we can look at in terms of numeric data. All right, a couple of other things. I want to go back to that idea of the standard deviation and also how that's related to the range. Your book calls kind of an estimate or a rule of thumb. And there's actually a couple different rules of thumb that your book talks about. One rule of thumb is that a standard deviation is kind of hard to calculate. There's a lot of work that goes on in calculating that standard deviation. But a standard deviation is going to be pretty close to whatever the range of your data is. Okay, so the max minus the min. And then if you take that and divide it by 4, that'll give you a pretty good approximation of what the standard deviation is. All right, so for our example, our range was 14. We divide that by 4, we're going to get a standard deviation that is 14 divided by 4 is 3.5. Okay, that's a pretty good rule of thumb estimate for what the standard deviation is. All right, now our standard deviation was actually about 4.4, but this is going to give me a kind of a rough estimate about how big that standard deviation is going to be. If I don't have all the information and I don't want to go through the entire calculation of that standard deviation. All right, the other thing is there's a rule of thumb for what is called usual or what's called unusual. So a lower bound on usual values in a distribution. All right, so in our case, we're talking about heights. If I wanted to know what would be the shortest person, or what would be somebody's height that we would say is kind of the boundary on what we would say is unusual here. All right, well, the lower bound on what's usual is going to be 2 standard deviations below the mean. So if we take the mean and subtract 2 standard deviations, this gives me kind of a bound on what I'm going to consider to be unusually short. All right, so in our case, the average was 66 inches. And if I take 2 times the standard deviation, that standard deviation again was 4.416. And if I do that calculation, 66 minus 2 times 4.416, that gives me a lower bound of 57.168 inches. All right, so if somebody in this group was 57 inches tall, that's the boundary on what we would call kind of unusually short. Okay, our shortest person was only 60, so there's really nobody in this distribution that we would consider to be really unusually short. Okay, now there's also an upper bound on usual values. And the upper bound is to go 2 standard deviations above the mean. All right, so if we take 66 and we add 2 standard deviations, so we're going to take 66 plus 2 times 4.416. All right, and when we do that, we get 74.83. And 74.83 inches, so this guy that's 74 inches tall, he is, by this rule, not really unusually tall. Okay? All right, so we could end up with some people in our distribution that are unusually tall or unusually short. In this case, we didn't get anybody that was really outstanding. All right, now, one other thing, or actually there's 2 more things I want to talk about. One is the idea of what about if a distribution is approximately normal, right? And we're going to be looking at a lot of normal distributions. Okay, we talked about a lot of distributions that would probably follow a normal curve on last Thursday. And if this is a normal distribution, think about this as being a histogram, and this is just kind of the general shape. Right, so the mean of this distribution is going to be right here in the middle. Okay, if a distribution is symmetric, the mean and the median are going to be exactly the same number. Right, and then we're going to label a standard deviation. The standard deviation for a normal distribution is going to be, if you think about it, this graph is kind of bending downward here, and then when we get over here it starts to bend upward. About the point where that concavity changes is 1 standard deviation. Right, so this is about where x bar plus 1 standard deviation would be. All right, then if we go out here a little bit further, we'd have x bar plus 2 standard deviations. Right, and because this graph ends up getting very, very small over here, we can see that this would be our boundary for what we would say is unusually high. All right, we're going to also go out here to x bar plus 3 standard deviations. And we're going to look at that on the other side as well. X bar minus 1 standard deviation, x bar minus 2 standard deviations, and x bar minus 3 standard deviations. All right. Now, one thing that's really nice about a normal distribution is that we can actually calculate what proportion are going to be in or within 1, 2, or 3 standard deviations of the mean. Okay? And you've got a rule called the empirical rule. The empirical rule says that between 1 standard deviation below the mean to 1 standard deviation above the mean, you're going to find approximately 68% of all values in that distribution are going to fall between those two numbers. Okay, and if you go out 2 standard deviations, you're going to find that 95% of all of your observations are going to be within 2 standard deviations of the mean. Okay, so only about 5% of the observations are going to be unusually high or unusually low. And if you go out 3 standard deviations, you're going to end up getting just about everybody. 99.7 is going to be within 3 standard deviations of the mean. Okay, this is the empirical rule. It gives us a way of estimating what percent of the data is going to be in different parts of that distribution. Right, so for example, suppose that we talk about IQ scores. And let's say that IQ scores have a mean, and let's say that that mean is 100. And let's say that they have a standard deviation equal to 15. Right, and suppose I wanted to know what proportion of IQ scores are between, let's say, 85 to 115. All right, now if the mean is 100, then 85 is 100 minus 15. That's 1 standard deviation below the mean. 115 is 100 plus 1 standard deviation. And so really what we're talking about is what percent are going to be between 1 standard deviation above and 1 standard deviation below. Our answer to this is we can expect about 68% of all IQ scores are going to be within 1 standard deviation of the mean. Okay? I could also say what proportion are going to be bigger than 115? Bigger than 115. All right, so greater than 115, we're talking about more than 1 standard deviation above the mean, so we're talking about over in this range over here. Now, if we think about underneath this normal curve, we're going to end up with 100%. And if we've got 68% from here to here, that means there's got to be 100 minus 68 left over. There's going to be 32% over here, and there's going to have to be 32% left over here as well. So we'd expect that about 32% of the population is going to have IQs that are above 115. Okay, now we're going to give these numbers kind of a special name, and the name that we're going to give them is z-scores. Okay, and the z-score for 85, the z-score for this 85 has a z-score of -1. And that -1 just means 1 standard deviation below the mean. And the way that we're going to calculate that is we're going to take the value, say x, in this case x is 85. We're going to subtract the mean, in this case 100. So we're going to get 85 minus 100 is negative 15. That tells me that 85 is 15 units below the mean. And then if we divide that by a standard deviation, that's going to give me how many standard deviations above or below the mean a particular value is. Okay, so let's say that somebody had an IQ of 105, and I want to calculate the z-score for that 105. All right, so to do that, 105 is x, the mean is 100, and we're going to divide by 15. All right, so when we subtract those, we're going to get 5 out of 15, or 1/3, is 0.3 repeating. All right, so somebody who has an IQ of 105 has a z-score of 1/3, and we would say that that person is 1/3 of a standard deviation above the mean. Okay, and we're going to talk about z-scores quite a bit in this course as well. But for right now, there's just a couple of problems where you have to calculate that and interpret it, and then we're going to talk more about z-scores when we talk a lot more about normal distributions. Okay, for right now, we're just saying that some distributions have that kind of a shape, and these are some of the things that we can kind of take away from a normal distribution. Okay, the empirical rule is going to be, again, kind of a rule of thumb for a lot of the calculations that we're going to do. All right, so again, I apologize for this video getting out a little bit late, but you should watch this video. You should work through section 3.2 and 3.3. Those two sections are about measures of spread and measures of center. And then on Tuesday, I'm going to take some questions on those. And I'd also like to give you a quiz on Tuesday over just finding the mean, find the median, and those kinds of things. So come to class on Tuesday with questions. We'll start out with those and a quiz, and then we're going to move on to the next stuff in the book. Okay? All right. Have a good weekend, and I'll see you on Tuesday.